Okay, formal geometry. So my goal was to be able to do this in person, but I'm just gonna have to make a video. And what I want to do today is go over the 4 homework problems that I assigned in our last class. So this was your first exposure to doing real 2-column proofs involving 2 triangles being congruent. So I did a bunch in the last video, but these are the ones that you had to do in your homework. So what I want you to do is just kind of look at what you did, compare it to what I'm doing, and then make any changes as you need, and basically just kind of see how you did. So I'll just walk through all of these. This first one, given that JO is congruent to KE and JK is congruent to OE, prove triangle JOK is congruent to triangle EKO. Well, we got statements. And we got reasons. We're going to start with just the given. I'll just copy this directly. JO is congruent to JK. And KE, whoops. And JK is congruent to OE. That is given. Now the next thing we are going to want to do is look at our picture. Do we have any visual freebies? Do we have vertical angles? No. But do we have a shared side? We absolutely do. So KO is used in both triangles. So we can say that KO is congruent to KO. Now if you put OK is congruent to OK, that's just fine. Or you could say that's okay. That's a joke. You can put reflexive property for that. We did that like 4 times in the video the other day. And now if you look at your picture, you have this triangle up here with 3 sides, the triangle down here with 3 sides. So we can say the triangles are congruent because of side, side, side. So triangle JOK is congruent to triangle EKO because of side, side, side. So if you did that and you did it just like this, maybe you did okay and it's congruent to okay, you should feel really good about where you're at. That's a really good job. I know this is our first one, and if this would have just been on the how could you say they're congruent page, it maybe wouldn't have been so bad, but putting this down in 2-column proof form, that's what this should look like. So I'm going to do this next one. I'm going to give myself a little bit more room. This one is probably one of the harder out of the 4 that you were assigned. We're given AB is congruent to CB, that's marked in. We're also given that BD bisects angle ABC, and this is maybe the hardest part. We want to prove the triangle on the left is congruent to the triangle on the right. We'll write down our given. AB is congruent to CB, and BD bisects angle ABC. Next thing we always do is look at our picture. Do we have any visual freebies? Do we have vertical angles or a shared side? We have a shared side again. So both triangles use BD, so you can say BD is congruent to itself. That is our reflexive property. Once again, you could have done DB is congruent to DB. The order of that doesn't matter. And now this, if I had to guess, this is where people maybe made a mistake. BD bisects angle ABC. Angle ABC is this top angle up here. That thing. And we're told BD bisects that, or BD cuts that in half. So what that means is if that purple angle was being cut in half, that means this angle here has to be congruent to that angle there. BD bisecting ABC tells you nothing about anything down here. My guess is some of you are tempted to say that AD and DC are congruent. You can't say that. All you're told is that BD cuts this angle in half, so these 2 blue angles are congruent. So that's what I'm going to put in the proof for my step 3. I'm going to name this left angle ABD. You could also name it DBA, but I'll go ABD. And say that's congruent to DBC. Once again, you could have named that CBD. For my reason, that's just definition of bisect. And now looking at the picture, if I'm looking at the left triangle and the right triangle, I recognize I can say that they're congruent because I have two sides and the angle between them, that's side angle side. So I will copy this directly. Triangle ABD is congruent to triangle CBD because of side angle side. Please note also that if you did these two steps in reverse order, that's totally okay. They're not dependent on each other. So you could have had definition of bisect as your second reason and reflexive as your third. That'd been totally fine. Okay, moving to the back page. I'm once again going to give myself a little bit of room. Given Vx is congruent to xy and xw is congruent to yz and xw is parallel to yz, oh boy, prove that the triangle on top is congruent to the triangle on bottom. Make our little T-chart, got statements and reasons. I'm going to put down the given, so bear with me. Vx is congruent to xy. xw is congruent to yz. And xw is parallel to yz. That's given. We want to somehow prove that these two triangles are congruent. Well, here comes the first proof that we've seen that does not have a visual freebie. There's no shared side. There's no vertical angles. You might have been tempted to say that these two angles are vertical. They're not. Remember, vertical angles have to be across from each other or kitty corner from each other. So, bummer. We can't use either of those. Now we got to move on to what else we're given. We already have two pieces being congruent. We now can use parallel lines somehow. We have xw is parallel to yz. We can recognize that these two horizontal lines are being cut by a transversal, something like this. Then you got a triangle up here and a triangle up here. So we recognize that these angles are corresponding angles, and those angles would have to be congruent. They're both above their line and then to the right of the transversal, above and to the right. And this wasn't super obvious. We haven't really done a whole lot of that this chapter at all. But these are corresponding angles. Remember, these are the ones that you can basically just shift and slide up the transversal. So we can name this top angle, angle VXW. Say that's congruent to angle XYZ. And we can say those are corresponding angles, just like we did in chapter 3. And now we look at our picture and we see pretty plainly that we now have two sides and the angle between them. So we can say the triangles are congruent because of SAS. Triangle VXW is congruent to triangle XYZ. This one and the one previous are probably the two hardest ones on the homework assignment. So to finish this out, let's look at the last one. We are given that AC is congruent to EC and DC is congruent to BC. Prove the two triangles are congruent. This one, kind of like the first one, should be a quick one. So AC is congruent to EC. DC is congruent to BC. That's given. We want to prove the two triangles are congruent. Look for our visual freebies. You guessed it, we got vertical angles. Mark those in, and then we just name them appropriately. Don't say angle C is congruent to angle C. Name the top angle appropriately, name the bottom angle appropriately. Use 3 points. So angle ACB would be okay. You could also name it BCA. Angle ACB is congruent to angle, bottom angle would be DCE. Those are vertical angles. And now, for the third time in a row, if we look at our picture, we have two sides and the angle between them. I promise they won't all be SAS, but on this assignment, 3 of the 4 were. Triangle ACB is indeed congruent to triangle ECD because of SAS. Lovely. Okay, your homework today is to work through the next few pages in the packet. It's the next proof worksheet. So you're looking at just 6 more proofs. It's a lot like what we just did. So we're doing all of proof worksheet 4. So it's these two, and then these 2. On Friday, or the next time we meet, we'll all come together and go through these as well.